All right, folks, we're going to get the show started here. Once again, I'm Travis Sturek, product manager here at Peplink, and as always, we are joined by Peter West, Professor P. And Peter, you've got some outbound policy stuff for us today. I'm excited about this one.
I am very excited about this one. I think, especially as SpeedFusion Connect is taking more and more popularity, the ability to control the flow of traffic is important. And I think that this is going to help people understand how we control that flow over different internet connections, especially when dealing with things like Netflix and things like that, and how we handle that. So
awesome. Well, let's dive in.
Let's do it. Thank you everybody for joining. And like I said, today we're going to talk about outbound policies. And there are outbound policies are basically, if depending on how you word it, are going to be traffic shaping in a sense. We're telling the traffic on your LAN how to use the different internet connections, what cellular connections, or Wi-Fi WAN, or Starlink, or bonded internet like SpeedFusion Connect, or just regular SpeedFusion going to your corporate office, and how we control the flow of traffic and what that means. And so outbound policies can be managed in 3 different ways. We can manage it right inside the SFC Protect kind of portal management interface, which allows for really simplistic policy management, specifically designed around which applications we want to send over SpeedFusion Connect. Or we can manage it right inside the router, like on the GUI. And we're gonna show you how to do that. And then we have inside InControl. And so the idea is using InControl 2 with SAS and regional capabilities, as well as grouped policies and then centralized management. So if you have a bunch of routers you've got to manage, InControl 2 brings all that together.
Yeah, I think for me, outbound policies was kind of almost like a light bulb moment for me. If I look back to when I first started using Peplink, I mean, it was a long time ago now, but most routers then had one port for an internet connection, right? And so there was no such thing as an outbound policy. But as soon as you have more than one internet connection, there's different places that you can send your traffic. There's different strategies for using those two, and there's different reasons for doing implementing those strategies. But then when you enter SpeedFusion, you've got 2 individual connections, but then you've got this super bonded connection that is your SpeedFusion tunnel. So again, you need this ability to kind of steer traffic in different ways and be able to take advantage of all those connections to the best that they can do.
And there's pros and cons to each one. I mean, there's limitations. A SpeedFusion has overhead to it. There is a native overhead associated to SpeedFusion, where if someone's looking for raw bandwidth and they have a gigabit connection, you might not want to have your regular internet traffic bonded or accidentally going out a slower connection unless that faster connection fails. And so we have algorithms designed to basically fit almost any scenario, and we'll review those different algorithms here in the presentation. And then I'm going to demonstrate them in real time I've got a laptop, an IP camera, an HD4 MBX 5G, and then 2 ADG antennas connected to my HD4 5G. And so I've got 2 AT&T, a T-Mobile, and a Verizon set up. And then we're gonna play around with the bonding there.
Yeah, I think you mentioned something that I think is kind of interesting, and it depends on kind of who you are or what perspective you're coming at this from. But for somebody who's coming into this conversation from an enterprise networking world where they're used to what's called often SD-WAN solutions, you don't always get a lot of these choices. It's kind of like something's done in the background and you don't really have control. Everything is tunneled, everything is sent through this SD-WAN pipe. And with Peplink, you've got full control. You've got the ability, like you said, something I just want to send right out my Comcast. I don't need to send my web browsing to a bonded connection. So yeah, I'll let you keep going here, but I just love that you pointed that out right away.
Thank you. And another, I built on that. Sorry, we kind of go back and forth and feed each other a lot, but I mentioned traffic shaping earlier, and a lot of times when I'm dealing with with enterprise specific, people that are really into the large enterprise networks, it's all routing. So where's my default route? What's my route priority? Where's my BGP handoff? and they're thinking negotiating with their ISP or the MPLS circuits, and they're thinking about how do I route this traffic? And we're not routing the traffic, we're shaping the traffic. We're SD-WAN or Peplink or supercharged connectivity. We're telling the router how I want that traffic to be handled. And so we're not routing the traffic with weights, where we're actually controlling the flow of traffic on a bunch of different options like TCP and UDP, IP, DSCP, source IP address, destination IP address, destination URL, destination SaaS application, Google or Microsoft Teams. And so we're able to control how your internet is using, or how your network is using your internet connections. And so it's a lot more powerful than just routing the traffic up to the next internet,
Yeah.
or ISP. And so routing, distributed routing / traffic shaping in Peplink equals outbound policy management. And so it makes a big deal on how we handle that.
And I think the other nice thing is, if you're coming at this from maybe the other end of the spectrum, where enterprise networking is not your world, it's not what you do. The outbound policy manager looks just like a firewall, and so it works very similarly. So if you've ever had to set up a firewall rule, this is going to start to kind of make sense quickly, I think, as you step through it. So
yeah,
there's something for everybody here to learn, as usual with the Peplink University.
And and kind of feeding off that too is outbound policies like firewall rules work top down. And so it's going to check on the very top. And if you see in this gray bar right here, which is really neat that Peplink did this in the creation of the slides, the first rule is this gray bar. And that actually is a rule. It's saying, hey, follow PepVPN, OSPF, BGP, RIP-v2, and SpeedFusion Cloud routes. In other words, if I know the destination via standard routing protocols that are available to me, use that first, then follow these policies. So it's kind of a default route optimization in a sense. But what's really cool is you can actually drag your rules above. So a lot of times, for example, someone will have his default route 000 goes into their core network. But for out of band management, I want to say if peplink.com, go out SpeedFusion Connect. So I'll actually say I'll move SpeedFusion Peplink, the destination peplink.com, above default routes. In other words, overriding the default 000 route that might be going into a core network, and saying, hey, I want to make sure out of band management is not being affected by a core uplink. It's taking advantage of these multiple circuits.
Very cool.
Yeah, accessing outbound policies and in control 2 is really easy. Under your in control 2 environment, you're going to go to network settings and outbound policies. And it's important here too is outbound policies on the router can work by grouped networks and access control lists, as well as source IP address, source network, destination IP address, destination network, destination grouped network. And so you can centrally manage these grouped networks and access control lists and in control. And I love this feature, and I've been showing it off a lot for enhanced security. But like, for example, say you have a group of servers in your corporate network. And so you can create a grouped network called servers, and you can list those servers. Then you can create an access control list, which are MAC addresses of your company laptops, your company PCs, or whatever. And then in your firewall rules, you can create, if the source is my access control list authorized PCs and the destination is my group network servers, allow that traffic. Anybody else, destination of those servers, deny. The same type of thing applies to outbound policies. I can say if the source are these devices and the destination is these servers or this destination group of IPs, send it over SpeedFusion, send it over WAN smoothing, send it over hot failover. Make sure these connections stay priority. And so you can use outbound policies not to enhance the reliability of those specific connections, just like you can use firewall policies to secure those connections. And so they all apply equally. And it's really neat that Peplink has thought about that and put it right forefront in the UI, and then centralize that in control, which means if you have 500 sites, you create one policy and they all follow that policy. If you need to add a new MAC address, it doesn't matter where that user is in the environment. You just add it to the access control list, and now they have access to that network. So it's kind of a really neat thing that Peplink has done with these grouped networks and access control lists.
Yeah, it just really, levels up the integration possibilities there. And I think you're going to jump into some even more ones here, but yeah.
Exactly. And so inside In Control, Peplink now has the ability to do SaaS-based outbound policies. So if I know I want to make sure, if I'm using Teams all the time, I can say, hey, if the destination is Teams, I want you to use WAN smoothing, or I want you to use dynamic bonding, or whatever it might be, to make sure that those connections are reliable. It doesn't matter what the destination IP address is. It doesn't matter where the country is. It doesn't matter what the source is. It doesn't matter if it's someone's phone and they're hopping on the Wi-Fi network, or it's a conference room. Excuse me. If the destination is Teams, bond that traffic. Make sure it's protected. Make sure it's resilient. Or if you've got a 10 gig fiber line at your office, you go, SpeedFusion's great, but we have a 10 gig fiber line. I want to prioritize that traffic over that 10 gig, and then only if that 10 gig fails, go over to SpeedFusion Connect to bonded 5G. Then you can say, hey, priorities this 10 gig fiber line, backup hot failover to SpeedFusion Connect Protect with dual 5G in my SDX. Now I'm using this 10 gig fiber line, this super low latency connection, for most of my traffic. And then only in that fails, I fail. And that's actually what I do in my office. So I have 6 gigs of fiber here. It's like 2 milliseconds of latency. So I'm not going to bond and add extra latency when I have dual 6 gig fibers at my office. I'm gonna fail over to that, because the likelihood of a fiber failure is limited. And so I'm optimizing the flow of my traffic based on a situation that might happen, but not going to happen often. Whereas if I had a cable modem or a DSL modem, or maybe I was running solely on Starlink and 5G, I want to aggregate that traffic all the time. I want to say, hey, always bond my Teams traffic, because the cellular network or the Starlink network can be variable, and I want to make sure that even though they're variable, I'm getting that consistent reliability with the Teams call, and so I can shape that over SpeedFusion Connect. We have 8 outbound policy algorithms to make sure that that the traffic is operating how you want it to operate. And I say this a lot, and people probably make fun of me for it, but it's why I love Peplink. They're not like, hey, here's an outbound policy, send the traffic over. Like, there's a lot of reasons why you might want to use one internet over another internet, or one tunnel over another tunnel, or one destination over another destination. And so, like, let's make sure we give people options. And it's like this, the ability to control and power, like control your network to suit your application or your mission. And Peplink does this with these 8 load balancing algorithms, soon to be 9. And and so we have weighted balance. Weighted balance it can be very confusing for people, and it's actually kind of like the standard. If you're involved in routing, if you're an enterprise engineer, or you're playing around with Cisco's, you're very familiar with weighted balance. Almost every route, every OSPF thing that you set up, or BGP, you can assign a weight to that route, which gives it kind of like an inherent priority, but it's really the distribution mechanism. If I have 2 WANs and each of them are weight 10, every other session is going to get load balanced over them appropriately. And if I say this wrong, Travis, please correct me, but every other session is going to get load balanced. So session 1 is going to go over WAN 1, session 2 is going to go over WAN 2, session 3 is going to go over WAN 1, session 4 is going to go over WAN 2. They're equal weights, so every new session is going to get load balanced equally. That's really good if you have 2 fiber lines, 2 cable modems, you have 2 5G modems, and you want to just make sure you're maximizing session distribution to take advantage of those the maximum throughput of each circuit. And they're kind of equal services that you're load balancing against. Persistence comes into play when you're talking about more SSL traffic, right? When you're saying, hey, I need to make sure as soon as a session is established, all traffic going to that destination for the duration of that session stays there, because you don't want to have the IP address changing during an SSL transaction with your bank or with Teams or any kind of SSL traffic that's IP persistent requirement. And so persistence says, once you establish a connection on WAN 1, stay there until that session is terminated. And so persistence is really good for creating reliable SSL sessions over multiple WANs. And that is important, especially when you're looking at everything going SSL these days, making sure that those sessions stay resilient. Now, I've seen some cloud applications are getting better at handling that. Like you can do it's almost like you don't always need that, but there are applications where I've seen that you'll still you'll drop that that FaceTime call or something like that, and you're like, oh, why am I dropping that call? And it's because it's not persistent. So you have some overhead rule that's flip-flopping your WANs, and so FaceTime is renegotiating, and so it's connecting, then renegotiating, connecting, and that's what's happening. That call is being renegotiated as the sessions move. And so session persistence allows you to force that traffic out the same WAN once that session is established. Enforced says, I want you to always use this internet connection, whatever it is, and whether it's up or down. Enforced says always use it. This is good for where you have particular a whitelist, or you have a need. We've used this for Windows updates. Hey, Windows updates go over my fiber line. I don't want Windows updates going out my 5G, right? It like certain applications, Netflix or YouTube or Windows updates or things like that. I want you to always go over my Ethernet WAN that's not costing me money. If that WAN fails, it's just not going to work until that WAN comes back up. 5G, I mean, your regular internet traffic will work, but the other traffic won't. And so enforced is a great way of making sure certain traffic can't fail over to maybe a more expensive line. Another really neat use case for enforced is like guest networks. If you have a guest network and you have a cable modem or a fiber line or Starlink or whatever, and those traffic are fast, and then you're failing over to like a 5G or a more expensive satellite, like an SES or something like that, you might want your guest network to only use that cheaper internet. And so you can say, if the source is my guest Wi-Fi VLAN, go out this internet connection. If that connection fails, my guests lose internet. I can still operate over the more expensive internet, but the guest network fails. And so the enforced is a really good way to make sure they don't accidentally use your more expensive line. Priority is one of my favorites in combination with probably lowest latency or fast response time. But priority says, hey, use this circuit, then use this circuit, then use this circuit. And the only way it's going to fail over is if the top circuit fails. And this is great if you're running SpeedFusion, which I always run SpeedFusion. So I like priority. It's basically saying, hey, use SpeedFusion Connect Atlanta, then use SpeedFusion Connect Dallas, then use maybe my Fusion Hub up in Azure, because the Fusion Hub in Azure costs me money, right? I have to pay for that bandwidth that's going to Azure. But SpeedFusion Connect, Peplink's hosting it, so it's their data. so I can send my traffic out SpeedFusion Atlanta, then go to my more expensive SpeedFusion Azure, and still maintaining reliability. And because SpeedFusion Connect is so reliable, most of the times that's not really going to be, you're not going to be flip-flopping between those circuits. It's in the event that there's some sort of data center outage there, hey, fail over to my backup SpeedFusion solution. Another good example of priority is Starlink and 5G. Use Starlink, then fail over to 5G, or use my Ethernet or my cable modem, then fail over to Starlink. And so you're basically saying, use this preferred connection, then fail over. And all of this can be based on source and destination. You don't have to do this to everything. So you're not saying all traffic, you're saying the source and destination and protocol that I choose, my Teams calls or SSL, or if the destination is netflix.com or whatever, or my source is my guest network. So you can control this, and then you can apply these policies individually based on that source and destination. And in my video here, or my demo, I've got an IP camera, and so I'm going to show you how make sure that that IP camera network is secure or is protected with SpeedFusion Connect. And so it's reliable as it streams to YouTube. So that's priority. It's going to use that first one, then fail over to the next one, then fail over to the next one, and it's only going to fail over if that connection fails. And so it's not going to be using any sort of algorithm to say, hey, is this the best connection? It's this connection, then this connection. Overflow. Oh, go ahead.
One thing that I see a lot is that priority and enforce get used often kind of interchangeably. And, you know, oftentimes enforce gets used when maybe priority was a better choice, because enforced is absolute, right? It is that connection or it dies. And so there's some gotchas that you kind of have to keep in mind here, because yeah, I really do want it to use this connection, but if it's a traffic that I do want to fail over, you know, you have to make sure that you actually account for that failover in there.
Yeah, you need to understand that if with enforced, if that connection that's being enforced goes down, it's not going to fail over or back up or do anything else. This is always going to use that circuit. And one of my favorite things to do is priority, but on one WAN. Because rules work top down, I'll say priority, SpeedFusion Connect, nothing else. Then there's a checkbox that says fail to the next rule. So if SpeedFusion Connect goes down, do the next thing. What's the next thing I want it to do? Maybe use bonded circuits, or maybe go somewhere else, but my priority is here, and priority has that checkbox that says, if that one connection in my list is down, go to the next rule. And remember, rules were top down. And so you can kind of get creative. You don't have to fit yourself to a box of that one rule. You can say, I want it to use SpeedFusion Connect, but if it doesn't, I don't want it to go to the next. I don't want it to go to one cellular connection. I want it to go back to load balancing, just load balance across those connections. Because if you just said priority SpeedFusion Connect, then cell 1, then cell 2, then cell 3, then cell 4, well, then what's going to happen if SpeedFusion Connect goes down, then everything's going to use cell 1 and nothing will use cell 2, 3, and 4. So you can say use SpeedFusion Connect, nothing else. Then if that fails, go to just a normal load balancing. Just share the traffic across cell 1 through 4. And that way you're taking the most advantage of all the circuits you have.
Yep. And then, you know, basically you're getting the ability to harness the power of multiple algorithms then, right? You're not boxed into, oh, I picked this one, so I have to do it this way.
Yeah, exactly.
It's
Yeah, you can go to lowest latency or fastest response time or something else better.
Yeah.
Overflow is almost exactly as it sounds. This one fills up, and then it goes to this one, and that one fills up, and then it goes to that one. I've never used this successfully. Travis, do you have a use case where overflow has been used?
This kind of opens a little bit of a can of worms, but there are some other algorithms within SpeedFusion as well. And so I've seen this used much more strategically inside of SpeedFusion, where, you know, it's all, and I think it maybe should be labeled bursting inside of SpeedFusion, because, you know, if you've got like a slow DSL, like that's, you're not paying per gig, right? There's no meter on it usually, but it's just like 10 megs. And it's great when it's, you know, when you're not maxing it out, but then when you are maxing it out, it's worthless, right? So, you know, overflow is to kind of like break beyond that 10 meg DSL and then, you know, strategically use my 5G connection that I'm maybe paying per gig on, right? So I'm not always using that 5G connection, but when I need the speed, it's there. But in practice, I see that work much more effectively within the SpeedFusion.
Oh, so once it needs more than 10 megs, so anything under 10 megabits per second, you're just like using that DSL. It's nice and cheap, it's free. But once your router needs more than 10 megabits, it overflows into the 5G, giving you more throughput.
Exactly. Yep.
That's a great use case. It really is. And once again, it's one of those things, you only know what you know. And you know, it's the use cases that you're trying to solve, but that's a really neat use case.
Yeah.
Least used is a really interesting one. What it does is every new session, the router knows you can program the router with the throughput available for each of your circuits. So this is a 20 megs of download with a 5 megs of up. This is a 100 meg download with a 10 up. And so what least used does is it says, based on the download bandwidth that's being consumed, use the internet connection that has the least download usage of all of them. So if I have 4 internet connections and internet, and cell 1 is using about 13 megs of download, and cell 2 is using 12.5 megs of download, and cell 3 is using 14 megs of download, and cell 4 is using 5 megs. The next session is going to start on 4 because it only has 5 megs of usage. And then if I start streaming Netflix on that and it goes to 26 megs, well, now cell 2, which has 12.5 megs, is going to be the next lowest used. And so what it's doing is every new session that is created is based on the current utilization, the downlink utilization of those circuits. And it's really nice for optimizing variable internet circuits. It's making sure that you're always kind of using the connections being used the least. And it doesn't have a lot of overhead. So lowest latency and fast response time have more overhead associated to them. Least used gives you that kind of capability without adding overhead to the WAN circuits. Lowest latency and fastest response time are very similar, slightly confusing. Lowest latency is a lower overhead version of fastest response time. So the idea of lowest latency is to make sure that the connections that are being established are connecting over the lowest latency connection. In other words, it's going to be the fastest response time because lowest latency. But it does it based on 3 hops. So the router periodically checks the latency out to 3 hops out and says which internet connection has the lowest latency to that 3rd hop. The 4th hop might not be as fast as the 4th hop of the other internet connection. We're checking to the 3rd hop. So it costs you less than fastest response time. And so any new traffic will go out the lowest latency connection to that 3rd hop. Fastest response time, every new session sends out an SYN on all available internet connections being calculated in the fastest response time. The first one to receive an ACK, that is the one that the session is established on. All other ACKs get withdrawn or get dropped. Do not do this if you have multiple Starlinks. You'll get either shut down or you get a call from Starlink saying you're flooding our network. Just FYI, don't use fast response time with Starlink. If you have 2 Starlinks and you're trying to use the fastest one, you want to use least used because Starlink is sharing up on the hubs. So on a least used, you're gonna be a more reliable connection. Lowest latency, fast response time, and ping-based type of sessions, they flood that network, and it creates a lot of messy traffic for them. So stay away from lowest latency and fast response time when you're dealing with Starlink. In SpeedFusion Connector and SpeedFusion, we have you can create multiple profiles, and we talk about this. And I'm not going to dig too much into it on this because we probably should have a dedicated SpeedFusion conversation. But the idea is you can create multiple profiles or multiple ways to use your internet connection. So you can say, hey, use dynamic bonding. Bonding basically says take the maximum available internet that's across my circuits, combine them together, and give me the most internet possible. WAN smoothing says send parity bits. In other words, if anybody watching this is familiar with like the old RAID arrays for hard drives, right? You take 3 hard drives and you RAID them. So you have the capacity of 2, and that 3rd one becomes almost like a parity drive. And so the data is being split across those 3 drives. WAN smoothing is very similar to that. WAN smoothing says, hey, make sure that my connections are being, my packets being sent across these 3 circuits are redundant. So if packet gets dropped on circuit 1, circuit 2 and 3 are carrying the load of that other packet. And so we're having resiliency there. And so what that does is it lowers latency and it decreases jitter. Because if the packet's being transmitted and then this internet connection spikes up to 1300 milliseconds, while the other 2 packets arrive, it just discards that 1300 millisecond session. Whereas bonding, you're limited, your latency will be the highest latency connection. So if I have 3 connections and it's 30 milliseconds, 40 milliseconds, and 100 milliseconds, bonding, I'm 100 milliseconds. WAN smoothing, it'd be 40 milliseconds. That 100 would just be discarded. And so So WAN smoothing costs you data in exchange for lower latency and or increased resiliency. And so Teams and video calls, YouTube streams, WAN smoothing is really nice if you're in unknown networks, 5G, Starlink, DSL, cable modems. They can spike. You can be at 13 milliseconds and then shoot up to 1300 milliseconds just because there's congestion on the network or someone starts a download and it exceeds your throughput capabilities. And so WAN smoothing helps ensure reliable connectivity, no matter like kind of taking those spikes into account.
Yeah, I think on WAN smoothing, a lot of people, I think, that come from traditional networking worlds, they get really hung up on this because they look at that and they say, well, you know, can't you just queue that better? Can't you just do, you know, where's the QoS here? Well, QoS on non-guaranteed links doesn't guarantee you anything, right? That doesn't actually achieve much because the network's super variable. So I can queue all day, and if the packets are getting dropped, I'm queuing for nothing, right? I'm not actually solving my problem. And so WAN smoothing is like brute force QoS, right? We don't trust any one of these links. We're going to use them both all the time, every time. And certain types of traffic, that's super valuable and useful, and you can justify that overhead. Not all,
Yep.
you know, not going to do that for your Facebook traffic, but for this call, yeah, I'm doing that. Definitely.
Ditto. Yeah, I mean, the idea is to make sure that that connection is resilient. And so that's the idea behind it.
I think one thing too that I want to just kind of like zoom out a little bit here is, and it's easy to get lost in this because this is kind of technical stuff, you know. So we looked at the different algorithms for the outbound policies, and you know, when you look at those choices of where can I send this traffic, it's going to show you, okay, I've got each individual internet connection, I've got my fiber, I've got my Starlink, I've got my 5G, and then it's going to also show you the tunnels. So I've got a SpeedFusion tunnel and I've got an IPsec tunnel. So those are different doors that I could send that traffic into, right? Now, inside of SpeedFusion, we're like doing outbound policy on steroids, right? That's where you're making packet level decisions. So you're going way beyond what any of those load balancing algorithms can possibly achieve. And so you're just kind of setting yourself up to have that success with the outbound policy manager. You're saying my real-time traffic, go to SpeedFusion where you can do that super fast packet shifting stuff where the normal internet can't accept that. So SpeedFusion kind of takes you up a level beyond what the outbound policy manager is capable of.
And I know they call me Professor P, but Travis, I'm going to challenge you on that a little bit right in front of everybody later, because when I go into the SpeedFusion Connect, I actually have a question that I want answered officially, because I wanted to understand SpeedFusion as a destination. And so we're going to play with that here live in just a minute once I finish these slides. So get you a little amped up on that one, but we're gonna address that live. So now I'm gonna do a demo. Oh, there it is right there. So we're gonna demo, and the first thing I'm gonna do is I'm gonna start simple and then go to complex. So we're gonna start with router-based outbound policies, and we're gonna just traffic shape based on source and destination, and what's built into the router. Then I'm gonna go into the SFC protect and its outbound policies, once again local to the router. And then I'm going to just quickly show the differences that are available in control versus SFC protect and the router. So that way you're not repeating information as we do that, because you're only adding capability on the 3 tiers. So let me pull up my router. So I have a, oh wow, that's big. Hold on 1 second, let me zoom in. Is that better? Is that visible or better for you?
It's great, yeah.
Okay, perfect. So like I mentioned, I have 4 internet connections. I have 2 AT&T, a Verizon, and a T-Mobile, and I do have SFC Protect enabled right here. And so we will play around with that. I've set up a Wi-Fi SSID already, HD4 MBX 5G, and I have my laptop wirelessly connected, and then I have a PoE camera connected. And what I did is under network settings, VLAN networks, I created a camera network. So VLAN 5 is my camera network, 192.168.5.1. And then in the router, I set port 1 under network settings, port settings. I set port 1 as VLAN 5. So my camera is on its own dedicated VLAN. And this is very common if you're in broadcast or video. You want your video traffic to be isolated from your other traffic. And there are special switches that have like NDI and SRT support that are really isolating that traffic and prioritizing it. Not really designed for the scope of this conversation, but in a lot of times you're going to isolate that video traffic. And so here we did that as well. And I'm just going to demonstrate how we shape that traffic. And then, and so I've created my VLAN there. And then I set my Wi-Fi SSID and have my laptop connected and actually my phone connected. So if I go to status, client list, you can see there's my tablet. I have my TV set up, so my smart TV over here, and then I have my phone on the Wi-Fi network as well. And so you can see smartphone, TV, desktop, and then my IP camera. If the type doesn't show up, you can actually click on this, go to custom type, and you can actually change the type to be the right type, and then it actually reports that to Peplink, as well as changes it. So if you're doing traffic shaping policy based on client type, you can customize your client type right there. Okay, so we're going to go to advanced. I needed to set that criteria before we do traffic shaping so that you understand where I'm defining those terms. And then I'm going to go to outbound policies. And so these are the native outbound policies that have been historically available in Peplink since like the first Peplink router. It's the ability to shape traffic has always been outbound policies. The default policies are session persistence based on source, and then basically the source any, destination any. If it's 443, enable persistence. And it's basically saying if I'm established an SSL session, stay on whatever internet connection I'm on until that session is terminated. Otherwise, auto. And honestly, that's a good basic rule. If you just have 2 or 3 internet connections that are about the same, that works. It's when you start to get into these variable networks that we have to worry about it. So I've got 4 5G modems, and they might or not be 5G depending on where I'm at. And so I want to ensure that I have a little better quality. And so I can add a rule, and I can come here and say SFC protect. And I can say if my source is any, my destination is any, my protocol is any, and I'll go into those more in a second. But I want to show you this priority one. I go priority, and I can say SFC protect. And then I can drag all these other WANs. Oh, by the way, we need a way to just move all the WANs because I have a bunch of WANs. And so I have to drag each one of them. But we get to drag all the WANs, and I'm going to stop here because I don't care about the VLAN WANs. And then right here, this is what. Oh, well, yeah, I've got all my VLAN as WANs. I was doing with the EPX, and I have the 40 VLAN WANs. I was like, so, and then when there are no connections are available, what do you want to do? So if SFC protect is down, what do you want to do? I say, oh, drop the traffic or fail through to the next rule. If SFC protect comes back, what do you want to do? Do you want to keep the sessions where they are, or do you want to force them, terminate them and recover them on SFC protect? A lot of times I say, hey, let those sessions be where they are. Once they're done, the next session will go on SFC protect. That way you're not terminating someone's bank traffic or iMessage or FaceTime or whatever. And so then I can hit save.
Yeah, I think now that last, sorry to interrupt, that last box, I hear people refer to that as like fail back. Do I, I failed over, do I want to fail back, or do I want to just stay where I failed over to? Both are valid depending on different.
Depending on your needs. And a lot of times I check that box because I just want it to go ahead and kick me back into it. I mean, because when you're talking about a mobile router, especially when I'm working like on my Sprinter van and things like that, the router will come up, sessions will start passing, SpeedFusion Connect will then go. And what I'm saying is, hey, just terminate those sessions and throw them over SpeedFusion, because that way now I don't have to worry about my one T-Mobile line being used when I have a whole bunch of internet for other stuff. And so I'd prefer the interruption, but some people don't like the interruption. Whereas for me, just a little blip of the connection during the boot up process doesn't bother me as much. I'd prefer to have that SpeedFusion Connect bonding rather than waiting.
Yeah, most times I check that failback rule as well. I mean, not all, but most times that's
like my default is to check it. But I figured giving a webinar, checking that box, they might go, oh my gosh, every time it drops me. So I wanted to explain why that's there. So this is sort of a weird default rule, and we kind of did this when we talked about Starlink and bonding, or dynamic weighted bonding. But the idea is that I'm basically just saying, hey, use SpeedFusion Connect. If SpeedFusion Connect fails, then go ahead and just go back to your normal rules. You know, session over, load balance my 4 internet connections, and then do what you do best, which is just load balance my traffic. And that it's funny enough, but that is a really good baseline setup. It's hey, send me over SpeedFusion Connect, but otherwise, if that fails, the downside here is my smart TV. If I'm trying to stream Netflix, sometimes SpeedFusion Connect can get blocked. From Netflix, they see it as a VPN, and my Netflix messes up. So I can add a rule, and I can say smart TVs. Don't use it. There, smart TVs. And I can say if the source is a client type, and I can say audio and video, and the destination is anything. And then I can say, what do I want to do? Go over the least used, because it's based on downlink, right? Or it can go over the lowest latency. This is a smart TV and it's going to be streaming content. I'm going to say go over the least used connection. And then which connections do I want to, oh, you can't least use cellular anymore in this. We won't use least used in this example. We're going to do lowest latency. And then I'm going to choose my 4 cellular connections. And so basically what I'm doing is I'm saying, hey, if Netflix starts a session, use the lowest latency connection. Least used, I forgot, is WAN only, because you actually base it based on throughput. And we're changing some stuff associated to least used, but for the purpose of this video, lowest latency is probably better than least used, especially over cellular connections. So I can select my cellular connections, and then what do I want to do? Once again, use any available connection or fall through the next rule. And so I'm a big fan of fall through the next rule and then terminate on recovery. Now that's really doesn't matter too much, because I'm saying, hey, here's my internet connections that I want you to use. But what's really cool here is a source client type. I'm not defining this TV. I'm saying if a TV connects to my network and it registers at an audio video device, use that. Let that traffic go out the internet and not be bonded. That way it's not getting throttled. It's not getting seen as a VPN to Hulu and Netflix and YouTube TV and things like that. And I can hit save. And then there you'll see this outbound policy now show up. It says my smart TVs are going to use the lowest latency connection every time a new Netflix or session is created. And then I'm not going to go over every rule, but just show you like weighted balance. Weighted balance just gives you all of your internet connections, and you can see those there. You'll see in weighted balance, there's no SpeedFusion as a choice. You can't weight a WAN with a SpeedFusion. It's going to be your physical or virtual WANs that are available there.
I found something interesting earlier where it let me do that. Let me see if I can pull it up again.
Like I said, I know we were playing around with different firmwares, and you and I are kind of in all the new stuff. So
yeah, it's just interesting. I'm on 830, and when I choose weighted balance, there's a connection type, and I see SpeedFusion or WAN, so it'll let me do either one.
Well, there you go.
I will send you a screenshot of that, but yeah, that's interesting.
Some firmwares are different. So persistent It's kind of interesting. You're gonna get this source and destination. So you can lock it by destination or source. And then load distribution, auto or custom. If you do custom, you're gonna get weighted. And so there's your weighted distribution, or auto is just gonna automatically send that traffic. And then what do you want to do? Drop the traffic, so that all you have is that, only drop the traffic. Enforced, choose an internet connection. It is that easy. And you can see there's my SpeedFusion Connect Protect. So I could say if the source is a client type and it's a tablet, destination any, enforced over SpeedFusion Connect. Or I could say if the destination is a domain name, client type is any, and the destination is a corp.app.com or whatever it might be, always SFC protect that. And so you can change based on source and destination. And like I mentioned earlier, we have IP address and network and MAC address, client type, and associated SSID. So you can say if the person is on a specific SSID, Wi-Fi SSID, send their traffic out. Priority, we just demonstrated that earlier, but you basically have your list of priorities. What's once again nice is you can either drop the traffic or fail through and then terminate back. And so you can use this in combination with other rules. Often I will have priority with just SFC protect there. And that way, then the next thing it does is go to a different rule that maybe uses those internet connections differently. Oop, didn't mean to close that, sorry. Overflow, you'll see there's your WANs. And the reason why there's no cellulars there is because overflow, you program your speeds. Cellular is variable. So you can't overflow a cellular connection based on variable throughput. There's no, like, you can't say, hey, the 100 megs, okay, once I get to 100 megs, but that cellular connection only has 20, it's just going to try to use that 100 megs. So it just doesn't work. So this is where you can program the throughput of the connection. Least used, once again, based on Ethernet WANs, because least used is sending out it's based on that download link. Lowest latency, it'll allow you to send out those third hops, and I showed you that earlier with the Netflix traffic. And then fastest response time as well. You'll get that list of the internet connections, but not SpeedFusion. So least used and fast response time can't be applied to WANs and SpeedFusion at the same time. This is where Travis is going to come in. If I change the destination, oh, where's my? Do I have to set up a regular SpeedFusion?
It's interesting. I know what you're looking for.
Yeah, but does it not apply to SpeedFusion Protect?
I thought it did, but let me look at mine.
I am running the patched firmware for Synergy.
Oh.
No, I'm running stock 830.559.
Yeah, I'm on 830. Let me check.
I didn't create a VPN. I could create a tunnel real fast. Let me create a SpeedFusion. I'm gonna pause my screen and create a SpeedFusion real fast, but I gotta type in a password. So give me just 1 second.
Yeah.
Sorry, everybody. I want to show you SpeedFusion as a destination. And I thought I could do that with SpeedFusion Cloud, but
I swear I've done that, but I'm looking for an example myself.
Yeah, I thought it was on SpeedFusion Connect, but I guess it's not, which is kind of funny.
Could have swore, but I sent you those screenshots too of the other one. I think you'll like that, but
it's creating the tunnels. I've never done that destination SpeedFusion before. I actually wanted to ask you about it on this webinar. But I know it shows up when I have SpeedFusion. So I mean, so I've seen this feature, and I've always wondered how it's used in application. And so if I go to advanced.
Yeah, I just tried this. I get the same problem. So yeah, that's
okay. Yeah, let me do it with an actual SpeedFusion here. And outbound policy. So now if I add a rule and in my destination, Oh, there is Speed Fusion. So like if my you see how the connection type, WAN and Speed Fusion now show up?
Yeah. Oh, so, okay. Yep.
So they moved it. But no, because now it's, did they get rid of that in 8.3? Sorry, I'm really sorry, everybody. I think both of us are a little bit,
Yeah, why
because there used to be a Speed Fusion option here in destination.
Yeah, I use that often.
Yeah. Okay, well, we won't talk about that right now then.
Never mind that.
Maybe they took it out in 8.3 because it wasn't used on. So we're gonna skip that part of it and be a little bit embarrassed. And we're gonna go to SFC Protect. And so the idea here is you can do it by source and destination inside Outbound Policies with your 8 algorithms. And that's what you're limited to, is source and destination, 8 algorithms, and then using those internet connections. In SFC Protect, I can come in here and I set up my client mode. And then I created my SFC tunnel, which is currently active. And then I can actually go into outbound traffic steering priority. So I can choose route by application, route by SSID, or route by LAN client. So I can send traffic destined for Zoom or Teams. So I can say if it is Zoom, go out SFC. If I have multiple SFC profiles, they'll all show up here. So if I had SFC dynamic weighted bonding, or SFC WAN smoothing, or SFC faster, SFC Atlanta or Miami, they'll all show up here. And then I can choose this, and it's going to go based on priority. So I can say Zoom goes out SFC, hit save, and it's going to send that traffic out the SFC tunnel. So if I go to Zoom, it's going to then connect SFC. Additionally, if I go, so that's optimizing cloud applications. Then I can route by SSID. So I can actually create an SSID called Speed Fusion Connect Protect, right? SFC Wi-Fi. And if I'm connected to that Wi-Fi, it's going to protect it. So let me show you that. Actually, Travis, do you mind explaining that? If I choose this and then I have this, could I then just say SFC Wi-Fi and then it creates the rule? Is that what that's for? Okay.
Yep,
I thought that's what it was for. I don't use this feature very often. And so basically I can choose my Wi-Fi, my HD4 MBX 5G, and then I can make a new Wi-Fi called SFC Wi-Fi, hit plus. And so now what's going to happen is I'll have another SSID created called SFC Wi-Fi, and that will, then I can then connect that SFC Wi-Fi, and it'll automatically bond that traffic that's anything connected to that Wi-Fi. So I can connect my TVs to it, my smart devices. If I have a work laptop and I just want all my traffic protected, I could do that. But if like my kids are on their Nintendos, or they're streaming something they don't need to stream, or not like don't need to stream, but like I don't want to waste data for an SFC Protect, then I can not have I just have them connect to the other Wi-Fi. So that's kind of a neat. I love the steering by Wi-Fi SSID. And then the last thing they have is by LAN device. So I can come back in here and go route by LAN client. And here I can choose my device. So if I know that my TV, my smart TV here, I can just say, hey, send this out, Speed Fusion Connect. And I don't have to worry about it. So you can specify a device, specify an SSID that anybody connects to that SSID is automatically goes out whatever profile you want. Or I can choose an application like Teams and Zoom. If you want, what I can do as well is go to client mode, SFC. And we have a video on this, so I shouldn't need to explain it fully, but I can say WAN smoothing, and then here I could turn on WAN smoothing on my connections, hit save, And now I have two profiles, a SpeedFusion Connect profile and then a SpeedFusion Connect WAN smoothing profile. And then that's going to allow me to use those profiles in the shaping policies.
So Peter, I think the mystery on the SpeedFusion destination thing, I found that same issue in my router GUI, but on the I'm managing the policies from in control on that router. So I think that that destination does show up on the IC2 side. So I don't know if that's a bug or if it's just because.
Okay, so it might be because I'm in control and it's hiding that feature for me on the GUI.
I think so, because
Okay.
I do see
well,
it
we can
show up
report
on
it
the
to Michael.
IC2 side, but anyway, it's driving me crazy there.
Yeah, I was a little embarrassed by it, but then see, now I have this WAN smoothing, so I can actually say, you know, WebEx can be WAN smoothed and Teams can be WAN smoothed. I'm going to get rid of the Zoom here, and Zoom can be WAN smoothed. And so now my WebEx, my Teams, and my Zooms are WAN smoothing, but then my business applications are SFC regular. And so you can use this. It's really easy. Like if you're just the end user, just trying to control the traffic, it's very easy to do that with this. And I know we're late on time, and I hope everybody has some time here. I'd love to finish this with in control. This is a lot more than I thought it would be, but there's a lot of good content here. So the last thing we're going to do is talk about in control traffic shaping. And so in control traffic shaping, we're going to just come into in control, and we can go into our outbound policies, and you can create those group networks like I mentioned earlier. So I can go into outbound policies, and when we go into outbound policies, there's two things to remember when doing outbound policy traffic management. One, it is highly sensitive to the names of the WANs. So in my router, my WANs are cellular 1, cellular 2, cellular 3, cellular 4, WAN 1, WAN 2, and then SFC and SpeedFusion, and then SFC WAN smoothing if I hit apply changes. So if I click apply changes, for example, and then it'll connect to that WAN smoothing one, and then I'll have this WAN smoothing one. If the name doesn't exist, the rule won't apply. So if you see an outbound policy rule that you created for SpeedFusion Connect and it's not applying, most likely the syntax, the name of the connection isn't matching. So therefore it's not applying. So it's probably maybe we misspelled it, or it doesn't exist on that internet connection, etc. So I can go into manage outbound policies, create a rule set, and then here I can click add rule. And you'll see that I get the same type of page here: source, destination, protocol, algorithm. And then here's the different WANs, and it's not giving my WANs, it's giving me the names. So, and that's why, like I was talking about priority and how annoying it is. Watch this. I can create that same priority. I can say SFC priority, and I can say source in any, destination any, protocol any, priority, SpeedFusion, SFC. Add. Fell through the next rule, terminate sessions. Okay. Now I have that same rule I created, but I didn't have to drag all those policies over. It's just right there. And so now my default rule here is bond to SFC. I can then add a rule that says web meetings. And I can go if the source is any, the destination is a SaaS, and then I can choose like Google and Zoom and WebEx and Microsoft Teams. And then I can say priority, WAN smoothing, with a tunnel, WAN smoothing. And see, I spelled it wrong. That's where it would fail. And then I can click add. And so I have my SpeedFusion Connect WAN smoothing tunnel. And then what do I want to do? Fell through the next rule, terminate sessions. Those are just my defaults. You don't have to do that. And save. And so now I've got a rule. It says web meetings are going to go over WAN smoothing if it is Google, Zoom, WebEx, Skype, or Teams. If it's not one of those, it's going to go over SpeedFusion Connect. If I add a rule here, again, in destination, if you look at the destinations, I've got a lot more now. I've got IP address, IP network, domain name, SpeedFusion or VPN network, which is what I wanted to ask Travis about. So I'll make another video just on that for you guys, because that does confuse me. Grouped network, SAS, like, so I once again choosing the SAS, or region. So I can say if the destination is the United States, do something, or whatever country you want to have. And so you can actually do regional based outbound policies. On my source, I have IP address, network, MAC address, and then once again, that grouped network. So we can control based on that group of IP addresses. And so in control gives us that flexibility to control, to make those policies a little bit easier to manage. And then it applied to all your routers as well, or a select router. So here I can say device selection on any of the following tags, all of the following tags, or devices with none of the following tags. And if you don't know what tags are, I do have an In Control 2 video where you can talk about tagging and the overview of just In Control in general. But the idea is that you can control the flow of your traffic, and there's 3 really powerful ways to do it based on your deployment topology and or your use case. And so that is In Control, and just adding that regional and SAS applications right into the router. I do have some Q&A, and so I'm going to see if I can pull that up. SIP isn't missing from a protocol. SIP is an IP. So someone asked if they see SIP is missing. It might not be available in the drop downs, but when you go protocol, you could do TCP, UDP, a DSCP, or IP. SIP is usually 5060, so you can say destination single port 5060, and then you would have like SIP traffic. So you could say SIP traffic is enforced, right, out my fiber line, or whatever you want to do there. In this particular case, it'd be a WAN one, or cellular one, or whatever you want to do. So if the protocol and the protocol selection doesn't have everything, but that's where the destination ports, and a SIP traffic uses different ports depending on if it's a Cisco or standard, and so you can customize pretty much any port based on destination. Least used downlink you can't do, as we learned live in this session, over least use can't be applied to cellular because we can't control the downlink bandwidth. So you're going to use lowest latency or fastest response time, or use bonding, which if you haven't watched our bonding video, I highly advise it, because it talks about taking the maximum advantage of all your cellular connections with dynamic weighted bonding. Ernesto asked a question about creating a star topology without using In Control. If you want to email me, Ernesto, that would be a different conversation. You're more than welcome to email Travis@peplink.com or Peter@westnetworks.com, and we're more than happy to show you how to set that up. I've actually had 2 responses with India. I believe we do have an Indian partner, but you could reach out to Travis@peplink.com for services outside the US, and he'll put you in contact with the right partner to help you with that. Client type does not exist in IC2. It is directly in the GUI. And so Ricardo asked, and we can see that right here, source is different. And so there are different options depending on your use case and design. That client type is sort of a lookup that's happening local on the device, and you're linking those clients in the status client list. I would assume that's going to come to In Control later, but a lot of times when we develop a new feature, it gets pushed out to the router, then it gets pushed up to In Control, because with the router, In Control is interfacing with the router. So often you'll see a feature come to the router just a little bit faster than it comes to In Control. Adrian asked a really good question about the SSIDs. I've never used that feature outside of this webinar. So for troubleshooting, I would love to work with you on that. Once again, if you email support@westnetworks.com or Peter@westnetworks.com, I'd be more than happy to get you in contact with an engineer. But Adrian basically said that associated SSID only works on traffic with the internal AP. I've never, in production, never used that feature, so I wouldn't be able to speak to it outside of the context. But I'm glad that you know that, and I'd love to work with you on potentially solving that. Adam asked a question about notifications of LANs. There is a LAN status, but not a monitoring. That would be like maybe like an SNMP agent monitoring your LAN network. The Peplink is really monitoring your traffic through the router, not on the LAN. And so I would look at an SMP agent, or like a I mean, we use Site 24/7 to monitor agents. So you could use like a monitoring tool like that to monitor the status of LAN devices. Not really associated to outbound policies, but really cool question. Huh. Hold on one second. So Ricardo says, because we were showing this off here and SpeedFusion Cloud was missing, and he said we have to be in expert mode to see this. And I would like to test that real fast. So he says, turn on expert mode. And now we have that. So if I add a rule, look at you. Thank you, Ricardo. That's going to drive me in. So if you turn on expert mode, wow, look at that. You learn something new every day. I almost always turn on expert mode. I factory reset this router, and that makes sense. So you add the rule, and now I have my destination SpeedFusion Connect and SpeedFusion profiles. I will release an updated video with Travis about this. So I thank you, Ricardo. That's awesome. PepVPN is renamed SpeedFusion. SFC is Peplink's cloud service. So if like I have my own SpeedFusion server, I've got an SDX here in my office. I've got a Fusion Hub up in Azure, and so I can SpeedFusion or PepVPN to those destinations. SFC Protect or SFC is Peplink's publicly available bonding service. And so SFC is just Peplink's. A lot of our military customers say it's dirty internet. All right, it's like plugging in a cable modem. So SFC Protect is the ability to bond without any existing infrastructure. My other videos are on peplinkuniversity.com or West Network, youtube.com/West Networks LLC. I love creating content. If you have any questions or feedback, I love to make those videos and push those out, as well as share information. I'm really, I'm still stunned about the expert mode gotten changed on where that is. So thank you, Ricardo, for that. I throw out to Ricardo for answering that. Trying to see if there's any other questions. I know we're over, so I just want to be respectful of everybody's time. Thank you so much. I will release a supplemental video on that one question that I actually had, which is how do we effectively use that destination profile? Because I see it, but then it says enforced WAN, and I don't know if that's saying enforced inside the tunnel or if it's letting me then select that. I'm assuming you can say how the internet's used inside the tunnel. So basically, if I say SFC, and then I can say priority, use cellular 1, then 2, then 3, then 4, or I can say enforced over WAN 1, which would be like Starlink inside SFC. I'm pretty sure that that is the case. I've just never applied it in practical use. I'm a huge fan of the bonding technology as a whole. But I'm assuming that when you do destination SFC or SFC Protect, what you're doing is you're saying inside the tunnel, how do I want to use those WANs? So I could bond fiber and cellular and then say always use the fiber line. And then if the fiber fails, then go to cellular, right? And that would be the priority. You use my Ethernet line, then use my cellular. Or bond it. So that's why I just having Travis. So I'll work through that. But once again, thank you, Ricardo, for letting me turn that feature back on, because new firmware, they changed that. Any other questions? Okay. Well, in that case, as I say, thank you so much for listening to us today. And once again, we'll see you next month on the second Tuesday of the month. If you have any suggestions that you'd like to learn or talk about with Travis and I, it's going to be, you can email Travis at peplink.com or Peter at westnetworks.com. If we do choose your stuff, you might get some free swag. So if you have any suggestions, throw it out there and we might send you some swag. So thank you very much and have a great day.